Chapter 16 introduces statistical graphics procedures. These graphics procedures are newer in the releases of SAS, and they use ODS graphics that we've seen, or that they're in that style of ODS graphics that we've seen as support for the univariate frequency reg procedures, just to name a few. And so they have a lot of background formatting already coded for us. They produce some nice pictures with very little code. We can learn to change some of those colors and options, and we'll look at a few ways to do that. So these are kind of the SG procedures. You'll see SG at the beginning of their name, and in particular we're going to deal with SG plot, SG scatter, and SG panel. These two, SG design and SG render, are more advanced topics and not covered here in this book, but with very little code we can generate some nice pictures using these three options or these three procedures, and so that's what we'll be looking at in this chapter. And as I said, these are the SG procedures, so you see their names begin with SG, and so things we can still utilize in these SG procedures are titles and footnotes and by statements and label statements, etc. All these things still work here in statistical graphics procedures. We are going to learn a format procedure in Chapter 18 that could even enhance the images we're producing here even more. So let's look first at what kinds of graphics can we generate, say first with SG plot. The basic syntax for the SG plot procedure is quite simple. We have various chart statements we can select. You can select at most 2 chart statements per SG plot procedure line. So if there's going to be several charts made that differ and the different types of chart requests, we need to use more than one proc SG plot block of code. So we can control bar charts, pie charts, we can look at histograms, we can look at density curves. There are a number of things we can do within this SG plot procedure, and those are going to be summarized in the following table. I called them chart statements, but they could be a chart or a plot. So here we have bar chart, and if we want a bar chart similar to what we saw with proc G chart back in Chapter 5, we have H bar and V bar. And so for an example, then you just write H bar, what discrete variable you want, and then we'll look at what options are available to us. Similarly, V bar. Now you may recall from proc G chart, if we wanted a histogram, we used either H bar or V bar, and we specified 0 spaces in between the bars. In this SG plot procedure, there is a histogram plot statement and chart statement in here, and so you specify the continuous variables, so it takes care of that spacing for us. Density curve. So if we wanted to overlay, let's say, a normal density, we can do that here. We can look at box plots. They can be horizontal or vertical. And then XY plots, so two-dimensional plots, so they refer to as a scatter plot or a series or line plot. And so what you have to look at then here on a scatter plot is name your axis, your vertical axis variable and your horizontal axis variable. You can overlay, say, 2 vertical bar charts if their axes are compatible and the number of bars are compatible. And so we'll learn how to do that. We may need to adjust in each of those the colors of the bars or perhaps the width of each bar. Commonly, a histogram overlaid with a density curve, that if the histogram is to give you an overview of what the distribution looks like, and so we can draw in a probability distribution and overlay that on top so that histogram and density can go together. And then likewise scatter plots and series plots. So if you think about the regression fit plot we got, where we have the original data as a scatter plot, and then we have the regression line in it as a type of series plot or line plot. So those things can be, if compatible, can be overlaid. So let's look at how we can construct some of those charts and see what they look like by default. And so I want to use the BEEF3 SAS dataset created in Chapter 14 and produce the default horizontal bar chart for the category variable sex. So I have proc sgplot, and that dataset BEEF3 is a permanent SAS dataset. I created a library, that folder on my G drive, that's my name, and I've referred to that as demo for demonstration. So I have demo.beef3. I wish to look at the H bar or horizontal bar chart for the variable sex that's in that data set, and so that I can take this information, submit this. Okay, so this is the default horizontal bar chart. So now in the video you'll notice that there's a very light gray or light blue here in the background. The bars are each a lighter blue color. In the book I'm limited to black and white, and shades of gray, so you can't see those color choices that SAS has chosen by default here. But so what we end up then with are heifers and steers. It's a frequency bar chart. Remember, this data set we had 3 producers, and so producers 1, 2, and 3, they each had, producer 1 only had steers in the data set at that time, and the other 2 producers did have both heifers and steers in their beef that was processed. So that's just what we get by default here for the discrete variables, and so I didn't have to make any choices here since these were categorical values for heifers and steers. In objective 16.2, we want to construct a horizontal frequency bar chart for the categorical variable sex for each producer. So we can sort the data first by producer, and then we can run sgplot by producer. And so that I'm going to end up then with a horizontal bar chart for each producer. Okay, so this is producer 3, so this looks a lot like the very first one we had in objective 16.1, but you'll notice the frequency axis here looks quite different here. So I'm going from 0 to 60 in increments of 20, up here 0 to 80 in increments of 20, and that's at the top of that screen. If I scroll up, that's producer 2. Producer 1, that does not look very informative. There is only one sex, or the steers only in by producer 1, so this isn't the best way if we wanted to look at a side-by-side of how all these producers compare and have them on the same set of axes. Now we recall in Proc G chart where we could introduce a group variable on the H bar charts that we generated using Proc G chart. Now I don't want to do that. The group option here does something quite a bit different than the group option back for the G chart procedure in Chapter 5. Now in those H bar and V bar statements there is a slash, and then you can list the options. So these options that we list here can be the following. The bar width, you specify a value of lowercase b. 1 is its default setting, so if you said bar width equals 0.7, that's going to make the bar widths narrower. Here again we see this vertical bar that's in SAS notation in their help and documentation, and what that means when you see this thing separated by a vertical bar, it's pick one. So either fill the bar or a no fill. So in no fill, it's just going to produce an outline of the bars only. This is that group equals, and we want a category variable selected here, and so this is going to divide the bars up into pieces to accommodate this other group. That's something a bit different than what the group option did in G chart, so kind of proceed with caution there. You can only do this when you're looking at frequency bar charts. I'm going to skip down one. You can also choose, like we could in G chart, whether we wanted the bar length to be represented by the mean or the sum. We had those two options, or the frequency. Here we also have the choice of a median, and for which response variable. So there has to be another variable that you want the mean of for each of these groups, and so that's typically a continuous variable. And so if we don't specify a response or don't specify a statistic, we're going to get frequency bar charts. If you request the mean or the sum here, you can also pick confidence limits on the bars, and you can choose at what level you want those bars to be drawn, or those bands to be drawn. So you want both limits, upper only, lower only. Again, pick one when you see the vertical bar chart. The default here is going to be 95% unless we select otherwise. So the values for P then are between 0 and 1, but typically closer to 0 because we want 1 minus P as our confidence limit. And so those limits then would be associated with it whenever you're looking at means here, if you wanted a confidence interval for a mean. Remember, if we make multiple chart selections in a single SG-plot procedure, they're going to overlay those. And so choosing the transparency of the bar and the color of the bar is going to aid us. That way we can put a more transparent bar on top so we can see what's behind it. And you can choose a color. So the color choices here, there are a few listed. And so just starting out here, I just say keep it simple. And so the things you're able to tell differences in: black, blue, red, green, orange, purple, gray. Yellow and orange are, yellow especially is really hard to see on a graph unless you're changing background colors. We will learn how to look at a more extensive color palette in section 17.1. But as we're starting out here, the simple choices are best, so we don't get too crazy. And transparency, again, choose values between 0 and 1, where 1 is at the highest level or it's solid, and then whenever you choose something less than 1, it becomes more transparent. In Objective 16.3, we're to use the BEEF3 SAS dataset and produce a bar chart for producer 3 for the sex variable. Let the length of each bar represent the mean of the average daily gain, or the mean ADG. Include 90% confidence intervals for the mean ADG on each bar. And so what I have here then is, I'm not going to modify the data set any. I'm just going to use all of the data, but with a where statement selecting only producer 3. We saw the by statement in use in the previous procedure, but here I'm just selecting a single procedure using the where statement. Still looking at H bar. I could switch to vertical bar if I wish, but we're looking then for each of the sexes. Compute a mean of the average daily gain, and then alpha is equal to 0.1, and we're looking at for both confidence limits. And so we see that same color light blue bar, and we have then the confidence bands here because this goes down to 0, and we have a large amount of data. Our bounds here aren't very large. Okay, they do overlap with each other, and so that gives us our confidence intervals then here are going to be really close to 3 in both cases, or containing 3 in both cases. So if we want to look at overlaying those, this seems to be a good place to introduce that. You have to overlay things that are on a compatible type of charts as SAS sees that, but also in terms of your data. So it makes sense that we could look at ADG and DMI on the same set of axes, because but it wouldn't say make sense that for us to compare let's say the carcass weight with ADG. The scales of the data there are just so completely different that they wouldn't fit or work well overlaying these. So I want to overlay 2 charts. I want to let the bar length be the mean of the ADG, such as we did in the first chart, and I want to add to this a second chart with the mean of the dry matter intake in the second bar chart, and I want to lay one on top of the other. So which one's which? Okay, so we're going to put the first one in, and we're going to use black bars here. That's our fill attributes, and so that's how we can specify the color. And then for the DMI, I've got a transparency of 0.5, and the fill attribute is our um, we're using the black color here again. And so that wraps around in your textbook when you see that. All right, down here at the bottom, we haven't been watching the legend down here, but the darker black is the average daily gain. And so from the previous chart, we saw those were around magnitude 3, so we can see those two bars here. And then the transparency of 70%, 70% of the black and a little bit narrower. We could have made them the same width as the others, but sometimes just adjusting the width of the bars a little bit let me see things that I'm looking at two different variables here, and so that it's labeled the average daily gain back here on the background. So if I look at the code, the average daily gain was plotted on here, and then we had the dry matter intake is in the background here, so it's hard to tell which one's overlaying which since this is a solid color black here. Alright, but so you may have to experiment with the order of these variables to get the overlay to look the way you want. Histograms here, we can specify options for histogram as well, and so that we can look at our the scale. We're talking about the frequency counts, the percent or the proportions, proportion being relative frequency. The width of the bars here, that's given by bin width. And so then if you have the number of bins and how many bars do you wish to have this represented, if you don't if you request a certain number of bars, SAS will determine the width of the bins. If you have a certain number, it tells us up here, if the number of bins is specified, the bin width option has no effect. You can overlay densities on those, so you can look at a normal distribution, or you can look at a normal distribution with specific mu and sigma values. You can either specify a mu only or sigma only or neither, so to overlay on your histogram. So in objective 16.5, we want to produce a frequency histogram for the carcass weight variable in the SAS dataset BEEF3 for all producers. Observe the default number of bins or bars and the bin width. And so that I look at this information, just what do I get by default? So histogram means vertical of carcass weight. It chose the values down here for me for the number of bars, and so I can change from that if I wish. I can change the color. I can look at and overlay say a normal curve on this to determine if the data are normally distributed, looking at that for comparison. In objective 16.6, we want to modify that histogram by overlaying that normal curve. We'll just let SAS compute the sample statistics for the x-bar and the standard deviation to determine the shape of this normal distribution. So that's why I just have type equals normal. It's listed second, so that's our overlay. And so we get this normal curve determined by the sample mean and the sample standard deviation. So you recall we've seen a graph similar to this, perhaps back in the univariate procedure. The other type of chart we've not yet looked at was a box plot, so we can look at those as either vertical or horizontal. For again, the dataset BEEF3, produce vertical box plots for the backfat response variable for each producer on the same set of axes, and we want to connect the means of the three producers. It gives us a visual for how the means change, and so that I do this by looking at VBox for vertical box plot of the backfat variable. Category here is how I determine that I need one for each producer on the same set of axes, and I want to connect together the values for the mean. And so That's what this does. So we can see that for producer 2, the mean is at an increase, and producers 1 and 3 have a more similar looking mean. I find those options for the box plots in table 16.4, and so that the category variable means that we got a little bit ahead of ourselves. We wanted to look at a box plot for each value of this response variable. So we want to be careful not to choose a continuous variable here that has a large number of responses, but a discrete variable with a low number of responses, so that you get a reasonable looking box plot, either vertical or horizontal. When you connect those together, you can connect means, medians. The median is the line across. The Q1 is the lower end of the box. Q3 is the upper end of the box, or the 75th percentile, or the minimums or the maximum score. So again, the vertical bars in here means pick one. You can either fill the box or leave it empty and just with an outline of color. And so again, pick one. And then the fill attributes, if you want your boxes of a particular color. So if you have a project, or if you work for a company that you tend to do things all in the same color, you can choose that color then for your box plots. How do you want the mean represented? So whenever we looked at that box plot, what did the mean look like? Well, we have choices of circle, diamond, what it calls a home down, that's like a home plate with the point down, square, star, and triangle. And then you can have filled shapes such as circle filled, etc. So here for the mean, the default shape was a diamond. And if I wanted solid diamonds, then as one word I could write diamond filled. So given the diamond and the home down, that somebody likes their baseball, it looks like. And so it says diamond here is the default. You can suppress values if you don't want the horizontal line across at the median. You can suppress that by saying no median, or if you're interested in connecting the medians, then you can turn off the mean, you can turn off the outliers, whatever it is that works for your application. Scatter plots and series plots are both on an XY coordinate system, and for compatible axes you can overlay one on top of the other. They do have some common options on each of those statements. First is data label, and so the value of that variable you specify here as the data label is used as a label in a scatter plot. If you don't specify that, then the simple value of y is used as the label. We have a group option here for producing different color plotting symbols for each level of a category variable, or for series plots we can look at a different color line for each value of the category variable. Line attributes, so you can choose different color options such as we've spoken about before. And now pattern options, this is new. Values for pattern are line styles, and so you can choose values from 1 up to 42 for different line styles. And so line 1 is a solid line, the others are all some form of dash line or dot dash, etc. In the SG procedures, the symbols used to plot a point are referred to as markers, and so that this refers to marker attributes. And so marker attribute, you can choose the color and also the symbol that you want used. And so the uppercase is the SAS, the italics you choose. So we've gone over this color just as same as it was in the line above. And then for the symbols, you can use the outline shapes, circle, diamond, home, down, square, star, and triangle such as before, or again you can fill those. And so by specifying the shape followed by the word filled with no spaces. Marker character, this is the value of the specified variable is the plotting symbol. And so we can look at some of these options then in our next objective. Continuing with the B3 permanent SAS data set, we want to produce a scatter plot of carcass weight versus dry matter intake for producer 3 only. We want to do this 3 different ways. Option 1, use black filled circles as the plotting symbol. Option 2, mark the plotting symbol with S or H indicating the sex of the animal. And option 3, using only S or H as the plotting symbol. Okay, so option 1, we select our marker attributes. We have black filled circles, y-axis, y is vertical, x is horizontal. So whenever you see in text, it's written as vertical by horizontal or vertical versus horizontal is the English statement, so you can figure out which one goes first. Again, we're limiting things to producer 3, so that's our first option. In the second option, it says to mark the plotting symbol with S or H, which is the value of the sex variable. I have this commented out. We'll learn some things in Chapter 19 where we can embellish that even better. And then in the third option here, again for producer 3 only, the marker character is the value of the variable sex. Okay, option 1 are black filled circles. Option 2 said we took the black filled circles out, and so the default symbol here was a circle, and then next to it put S or H for steer or heifer. So that's what they mean by data label. So you still have a symbol, you just change the value next to it. And in option 3 is to just use the value of this variable sex as the marker character. So if you had multiple letters indicating each one of the sexes here, this graph would get very congested. Also, I'm limiting this to producer 3 for this illustration for the same reason, but if I would have put all 3 producers on one graph, it gets very congested and gets very difficult to read. In Objective 16.9, we're using the Beef3 means data set, and we created this as a permanent SAS data set in section 14.3. And so what we have here are the means of carcass weight and for each producer and for each sex. And so I want to use a line plot, or what Proc SG plot calls a series plot, to graph the mean. So I have series on the y-axis carcass weight, x is the producer 1, 2, or 3. I'm grouping these by sex, and the line attributes then are that we're using a black color line with pattern equals 3, and that pattern equals 3 is a dashed line. The scatter statement says then to plot the data, the actual means here, and use the value for the marker character 6. So what's this? Because these are means, I'm not going to see the quantity of points in the scatter plot. Okay, so what changed here? So the first one, it just drew the lines. And if I wanted the plotting symbols to be indicative of the sex of the animal, that's why I have S's up here and H's here. And so we see that pattern equals 3 is this dashed line. Remember, producer 1 did not have any heifers in this particular lot of animals. Things we might want to do, experiment with, is look ahead at how can I get rid of these 1.5 and 2.5. That's really extraneous information on this plot. Notice we have a nice label here that's using the label for carcass weight measured in pounds and the full name of, and so that it took care of that, labeling this axis, rotating that, putting that at a comfortable angle. That is, it did it and without my making that request. The SG scatter procedure is a way of examining scatter plots of variables, and we have more flexibility here than we had using a scatter statement in the SG plot procedure. So this allows us to use what we call compare statements and matrix statements. So we've seen a matrix of scatter plots when we looked at the core procedure in a few chapters ago. Alright, so we're going to look at these options then within Proc SG scatter. So new procedure, 2 new statements. It's just these two statements we'll be looking at here. So you can, on the compare, the X and the Y, so this is your horizontal list and your vertical list, and those can be in either order. If you're going to have a list of variables, you need to enclose those in parentheses. You don't need to separate them by commas. We're given here options we can put on the compare statement to change data labels and marker attributes and transparency, such as we saw for the SGplot procedure. We also have a matrix statement here, and we can select options for the matrix statement that are the same as we see up here for the compare statement. In Objective 16.10, going back to the permanent SAS dataset BEEF3, we want to construct scatter plots of each of the following dependent variables: carcass weight, ribeye area, and back fat, versus the independent variables, dry matter intake and ADG. So we usually think of independent variables as those on the x-axis and dependent as those on the y-axis. And so you can see that we have those listed here in parentheses for each variable. We want to use black circles for our marker, and then the grid is an option. Then here it's going to draw reference lines in the background for us. Okay, so we have here the three variables we selected for vertical axis, the two variables we selected for the x-axis. We have open black circles. Then here these have the full labels because we labeled this data set in an earlier chapter when we created this permanent SAS data set. So that's what's nice about two things here: using a permanent SAS data set and then putting the labels of variables on there. All that information carries forward, really makes a nice appearing graph then. And so then we can look then at the patterns for each of these. We see that, and I think we saw this in the core procedure. We kind of have this one animal that's out here. It's a little bit smaller. There's kind of one down here, and we've also got this guy here. So those are some things that are would catch our interest as the beef producer. So the SG scatter produced this array that had 3 vertical, 2 horizontal number of variables to give us that 3x2 array of scatter plots. So if you look at a matrix, then you just list all of the variables here, and so that this here we can choose the same symbol colors here as we did in the previous objective. Gets much smaller. So now because it gets smaller, it's hard to see that these are what these plotting symbols are. It does get much more congested since we have a 5x5 array, and so it was a little bit easier for us to see all of this when we had only those 6 images up. I believe it's those were the ones we had, and so the things are a little bit larger. So it labels for us carcass weight is the vertical axis on these 4 plots, ribeye area is the vertical axis on these, etc. And so that you're going to look at this triangle up here of scatter plots. It's a mirror image of those below the line. So SG scatter is a way of creating a panel of scatter plots. Now then, we can also look at an SG panel procedure, which has even greater flexibility, in my opinion, than the SG scatter procedure. And so that when you write SG panel, then you know you're looking at a panel graph. And the panel by, you can choose what determines the number of graphs in each row and each column as these panel by variables. And then you can add your chart statements then here below. And so again, you can overlay compatible charts, but typically we just kind of go things one at a time. We also can look at different panel options here. And so that panel by is a required statement. You must have at least one panel by variable. And then the options, you can again opt to use or not to use. And so what are some of the options that you can use? Those are given in the following table. You can choose whether or not you have borders or no border. Remember, vertical bar, pick one. your column header position, where it's going to be at the top of the column, at the bottom, or both. It defaults at the top. The number of columns you can specify in an option on the panel by statement. Whenever you have row headers and column headers, likewise, you can also pick the position where the row headers will go. You can specify the number of rows, and then the layout, you can choose what you want it to look like. So if you're looking at a lattice, then you're looking at a row by column panel, and that's going to be whenever you specify two panel variables. Panel is just generic. You're kind of letting so for an R by C panel, you can have things arranged in a column or in a row, column lattice or a row lattice, and we can demonstrate those. These are just a few of the options available in the SG panel procedure. There are many more that control other appearances and in a panel graph, and where legends are located and that sort of thing. So we'll just start with the basics. In Objective 16.2, a vertical bar chart for sex was produced for each value of producer. Remember, those didn't look particularly attractive. It didn't allow us to make comparisons side by side of those. So we can arrange these three bar charts using SG panel with the default layout for the panel. So here I just panel by producer. I'm looking at a vertical bar chart for sex, and the fill attributes, I'm just going to not put any color in the bar, so I'm just choosing color equals white. So this is comparable to Objective 16.2, where we looked at H bar by producer if we were to go back to that image. Alright, so the default is kind of wrapped around here. We've got the same vertical axis for both of these, and so it just gave us the empty bars here. Because I don't have a fourth producer, I end up with this blank space here, and so this heifer and steer indicator down here at the bottom applies to the upper graph. Now when I chose the color equals white here, if you are limited to printing in black and white, such as I was for the book, that's one of the reasons for choosing black and choosing other grayscale compatible colors. So that's why we end up with color equals white. Works well. Objective 16.13 is that we're going to redo what we did in Objective 16.3, where we want to illustrate the mean ADG for each sex for producer 3 only. And so this time, can we put the rest of the producers in this and use a column lattice? I'm going to take the confidence intervals off for right now. Those could be put back in there because they are options for a V-bar statement. So all the options we had for vertical bar before still work here. So I don't have to relearn another set of options for V-bar, H-bar, etc. All those options from before still work in SG panel. And so that we're going to look at what does a column lattice look like and kind of compare that to what the default lattice up here, default panel, excuse me, looked like in the one above. All right. So here, each producer is in a column, and so remember there are no heifers in producer 1. So this gives us a better side-by-side than doing that proc SG plot by producer, where we had these really large graphs. They didn't have the same axes for us. They were, in that case, they were frequency distributions. So this gives us a little bit better image. We also see a new color here. Light gray is one word, is what I use to fill those in. I still have to look at the response in the statistic that's specified for the bar length. And so those, remember, are a little bit different than what we saw in the V-bar options in Proc G chart in Chapter 5. Objective 16.14 is kind of a rework of Objective 16.6. This time what I'm looking at is what does a lattice look like for the histograms, and we're overlaying a normal density. I'm paneling by producer and sex. Previously, I believe all we had was producer 3. And so how will this look? All right, so I had panel by producer and sex. And so the row headers here are at the top. Pardon me, column headers are at the top, row headers are at the right. And so if you don't like those, or if you want these row headers to be moved to the left, we can change that row header position, or you can use both. Similarly, we could move the producer for the column headers to the bottom or label in both places. And I've got that histogram overlaid on both of them. And finally, reworking objective 16.7, where we had side-by-side vertical box plots for back fat worth produced for each producer, and we connected the means. We can still look at that. I need to get one more option in here, so let's write in connect equals mean. And so that we have this as a row lattice, and so for each row we want the row header to be on both sides. We're just panel by sex here only, a vertical box plot for back fat thickness. So each row then represents each one of the sexes. Again, producer 1 didn't have that here, so I've got the row headers on either side. And so these are just some of the options then you can use to produce plots. So you've seen some of the places where I introduce color. And so you can do that anytime you have a bar. You can look at fill attributes. Remember, that's in the table. So I know I went through the objectives just like they were in the book. I'm trying to add to a little bit of explanation and give you a better feel for what's going on here. Longer video. I apologize for that, but one of the things I want you to be able to do is when you look at things by this point along in your development as a SAS programmer, you are hopefully less afraid to make a mistake. So if you're curious what an option does, try it. You're not going to break SAS, but just try it. The worst that's going to happen is that it's going to be an error and it doesn't work, and so then they'll just take it back out. So each one of these is kind of a starting point for different kinds of graphics that you might be interested in for your own projects. And so again, experiment with the options, experiment with the colors, and see what you can come up with.